7.3 logarithms, you should write this down. And if you have color coding, you should make a color coding like I did. So when we're talking about logs, this is a new math that we have going on here. Here we've been talking about exponential here, the first two chapters or first two sections. B is my base. When I raise it to an exponent, it's equal to the number. So let's say if I had 2 to the third, that's equal to 8. If for some reason we had something, so 2 would be my base, 3 is my exponent, and it's equal to 8. If I want to rewrite this, if I want to solve for a log, my base here is this little number. So if I want to rewrite this number as a log, this base 2 would be log base 2. I put this line here so that you know that this log, this is a sub number, so not right next to the g. It's a sub number. I'm going to be picky about how you write that. Now this x value is what this is equal to. So this is equal to 8. So this would be 8. If you plug this into your calculator, which I will get into, this would be equal to 3. So basically what log is doing is the inverse of an exponential. The bases here are the same. You will hear me say base often. One thing about this is that the inverse means the opposite. So log is the opposite of the exponential, just like adding, subtracting, multiplying, dividing, square roots, squares. See where I'm going with this? So when you're doing this, it says write exponential equations in log format. So again, use this as a reference. The first thing that you should do when you're looking at this is what is the base? So in this case, 10 is equal to my base. When you're writing this out, this is log, and then whatever your base is here, so in this case, it's 10, that's the little number, okay? Whatever this exponential is equal to, that's what you're going to be taking the log of. Whatever your exponent is what it becomes is equal to, okay? So again, looking at this as a reference, I want you to try to rewrite C, B, C, and D. So pause the video and try to write B, C, and D. So here my base here is 3. So I have a log base 3 of 81s, whatever this is equal to, is equal to your exponent. Here I have a log base 6 because 6 is my base. Whatever it's equal to is equal to your exponent. And log base 2/3 of 8/27 is equal to 3. So now here we started with exponential base and we wrote log base. This one we're starting with log base and moving into exponential. Same thing though, first you want to figure out what your b is. In this case, 3 is equal to my b. So your base now when it's exponential is 3 raised to what it's equal to. So undoing that is equal to whatever you're taking the log of. So pause the video and try to do B, C, and D first. First thing is figuring out what your B is, finding out what your B is. The second one, your base here is 3. So 3 raised to the 4th power is equal to 1. This should be a true statement. So you can always check this when you're rewriting. You should be able to do 3 raised to the 4th power and see if it's 81. 2 is your base here. This is your base. 2 raised to the 1st power is equal to 2. 5 is your base here. 5 raised to the negative 4th is equal to 1 over 625. So now we're going to be evaluating. So a couple of things that we can do here. I will show you how to do this in your calculator. 2 different ways that you can do this into your calculator. First, when you're looking at your calculator, you have a log button right here. Here's a log button. You have to be careful though, because when you type this log button, notice how no number pops up. If you ever see a log and there's no number, your base number is always 10. Your base number is always 10 if there is no number. So we can't evaluate log base 8 yet. What you can do is rewrite this. So this is log 32 divided by log 8. So log of your large number divided by log of your base number. That's an option. So log 32 divided by log 8. Plug that into my calculator. I'm going to change it into a fraction, math fraction. This will be 5/3. So this is equal to 5/3. So now if I want to rewrite this, I would go log of 125 divided by log of 5. My base here, again, if there's no number, that base here is always 10. If there's no number, it's always base 10. Now, there's another way. You can always do this, and depending on your calculator, you might not have the second option. You can also go to math. So I push the math button. If I arrow up this log base, now I have the option of choosing what my base is. So now I can go 5 of 125. If I did log of 125, Notice I close that parenthesis, divided by log of 5. Either way, my answer here is 3. Either way, my answer here is 3. So right now I want you to pause the video and try to do C and D. You should have gotten 2.5 and negative 5.6 for the last two. So again, I already kind of talked about this, but if you don't have a number showing, so if I just did log of 3 is equal to 5, let's say like that. If I want to rewrite this as an exponential form, if there is no number here, this number is always 10. So my base number in exponential form would be 10. Well, this is a wrong statement. I'm going to say that log of x. 10 raised to, remember, whatever it's equal to, raised to the 5th would be equal to x. So if I wanted to figure out what this number is, so if I change that, if there's no number, it's always base 10. So base 10 raised to my 5th power would be equal to x. So in this case, x would be equal to 1, 2, 3, 4, 5, 100,000. If for some reason we're looking for quantity instead of logarithm of a quantity instead of quantity, we are using logarithm scale. So if we're looking at this, if I gave you a question like this, if you saw this on an MCA or ACT score or test, really just look at what you have. I have a magnitude right here of 9.3. Here's a magnitude of 8.7. And saying I need to use this equation right here. So log of, I don't know what this is. I have to figure that out, is equal to my M1, so 9.3 minus 8.7. What this is asking for is the intensity. So I'm just going to write big I right there. If I did this 9.3 minus 8.7, that's 0.6. If I want to see how many times more intense it was, remember, if my base is no number, this would be 10. So I go 10 raised to the 0.6 power. If I do 10 raised to the 0.6 power, that would be equal to my I. So that would be equal to 3.98 intensity. I want you to try to do B by yourself. So it's the same type of thing, but in this case, I'm doing 8 minus 6.8. Remember, my base here, if there's no number, is always 10. So again, we're using that same equation right here. If we were like, what equation? It's that same equation. So it'd be 10 raised to the 1.2 will be equal to our I. So if we do 10 raised to the 1.2 in our calculator, we would get their intensity was 15.8. Actually, I would round this to 5.85. And there you have it. Bing, bada, boom. Going from logs to exponentials and exponentials to logs. We're going to get a lot more into logs. So there you go. Have a great, grand, wonderful day.